Okie doke. Right. So energy stores and systems. So it gets called energy stores. They're just different types of energy. Okay. So a little way that I remember it, and I know I've got a mixture of sort of year 9s and 10s with me today. The way that I remember it is I remember most kids today learn GCSE energy names because they do, you got to know them. But the first letter being the first letter of the different types of energy. Okay, so if we whiz through these first of all, oops, why am I right down at the bottom? So M, we've got magnetic. K is kinetic. That's about movement energy. I should put that in brackets for you. Okay. T is thermal. I could do with a bit of thermal energy right now. Freezing. L is light, enables us to see. G is gravitational. So anything that is at some form of height has gravitational energy. It's got the potential to fall due to gravity. We've got chemical, sound, elastic, oops. So anything that's stretchy, I'll try that for a third time, shall I? Elastic. So anything that's stretchy, when you put that under strain, so you have an elastic band, a bobble, anything like that, and you pull it, you've got it under that strain. I've got a bobble here, look. Yeah, so if I take that and I put it under strain, that has got elastic energy stored in it now, because if I let it go, it'll move, that energy will change. We've got electrical, loads of stuff, run off electrical energy, and nuclear. Okay. Now remember that energy is not created or destroyed, we just transfer it from one form to another. And when we transfer that energy, it will go as one of these four methods. It'll either be mechanical, electrical, heating, or radiation. So obviously these will be in the video. You'll have access to this to play this back if you want to use it as notes later. So mechanical, basically if you've got forces acting, you're thinking mechanical. Yeah, so when forces act on a body, so if a car was to collide with something, for example, that would be a mechanical energy transfer. I think electrical and heating are probably the two most straightforward. Heating is through things like conduction, convection, and radiation. And then we've got radiation in terms of sound that can carry energy from one place to another, and light. Okay, those two are traveling from one place to another. So what we're going to look at is we'll just look at an example of each type of energy and transfer first, just to give you like a real life example of them. Okay, so we could think about like a coffee mug, doesn't have to be coffee, some form of mug with a hot drink inside. That heat inside the cup will transfer to your hands. Yeah, so you've got that going back to this. Here you've got a heating, you've got a thermal energy transfer. Okay. So objects that are projected upwards. Okay, so to throw that ball up, there would be, whoops, kinetic energy. That as the ball has reached the highest point, it will be gravitational. Yeah. We've got a moving object hitting an obstacle. Okay, so we've got movement, so we've got kinetic, and as we're colliding with that, we're probably going to produce quite a bit of thermal. We may produce some sound as well. So sometimes there's more than one energy transfer. A vehicle being accelerated by a constant force. So that's that. We've got chemical that's in the fuel. and we're accelerating that, we're applying that force, so we're changing that into kinetic. Yeah, so just some examples of how these energy changes. We've got a vehicle slowing down. Okay, so we've got kinetic energy. And as we apply the brakes, we're probably transferring some of that, oops, I've done direct transfer then, to thermal. Yeah, boiling water in a kettle, we supply it with electrical. What we want to achieve is the thermal. We may get a bit of sound, we may get a bit of light. Yeah, so hopefully that's just giving you a couple of links to some real life examples. Okay, so if you get a question about energy transfers, as you will see here, they tend to be quite straightforward. It's usually fill in the blank, select the correct words from the box, any of those types of things. Okay, so we'll do what we've done before, give you I'm not going to give you too long. You need to fill in two words, probably give you about a minute. Have a read, write down the 2 words that are missing, literally because it's just worth 2 marks. You've just got 2 different types of energies to put in there to score you 2 marks. Remember guys, at any point, if you've got a question, just pop it in the chat. Okay, so this one then, as a cyclist rides along the road, there's something energy store in the cyclist body. Now, body, we have chemical energy. Chemical energy is a store of energy, could be stored as a fuel, like the petrol and diesel in a vehicle. In us, it's kind of like our food, isn't it? Our sugars, that's our store, it's chemical energy. The speed of the cyclist is constant when the work done. So this is drifted into a little bit of work done, but we'll link these back, so don't worry too much if you didn't get this one. Speed of the cyclist is constant when the work done by the cyclist is equal to or the same as the air resistance. Remember, that's about balancing forces. Don't worry too much if you weren't sure on that. Okay, again, really straightforward. If it's just talking about energy transfers, it probably give you the options. They're only worth 1 mark each because the answers are there. You've just to select the right one. So you're choosing an answer from the box. If it's not there, don't use it. It is there because your key thing is to choose the answer from the box. So again, just give you a minute or so to have a read, have a go, and then we'll mark it. Okay, hopefully you've had a go at that. Let me just open the chat box back up and minimized it. If I go too fast or I'm going too slow or anything, please do let me know. These sessions are just as much about you. Okay, so as the cyclist accelerates, the something energy store in the cyclist body decreases. That was dead easy, we just talked about that one. The chemical. So we've got to have energy in us to be able to power that bike along, because we're just transferring that energy. So it decreases, and the something energy of the cyclist increases. Okay, so we've got to think about what is he doing. Well, there's nothing stretchy, there's nothing elastic. We're not lifting anything up, so we can kind of rule those two out. Therefore, it must be the kinetic energy. So we're using our sugars, our chemical energy store in our body, to move our legs, yeah, which essentially then moves the pedals, moves the bicycle. So we're talking about kinetic energy. Okay, we've got one more. So we've got an image that shows a battery-powered drone. Again, complete the sentences, choose the answers from the box. Okay, don't put in your own words, you're just choosing the ones from the box. Okay, give you a minute. Okay, let's have a look at this one. So as the drone accelerates upwards, okay, so thinking about that movement upwards should give you a clue straight away. It's something energy. So something energy increases, so it's got two types of energy that is increasing as it's accelerating upwards. So it wouldn't matter which way around you put these, we're going to have its kinetic, because it's accelerating, it's starting to move, so its kinetic energy is going to increase, and its gravitational potential. Because as we're lifting something up, it's got the potential to fall due to gravity. Oh, squeeze that in. The something energy store of the battery decreases. So inside the battery, again, nothing elastic. We've used those two. It's probably not going to be nuclear in a battery. It could work, a little bit dangerous. So you're going to have the chemical energy. Batteries usually have an acid or an alkali in them. So the chemical energy, as that battery is being used, will decrease. Okey-doke. One last one, and then we'll have a look at calculating kinetic energy. So we've got a student that jumps off a bridge. If you have a look at the image, they are attached to a bungee cord. Bungee cord, I can't say that, bungee cord extends. You can see that the student comes to the lowest point just above the water. So use the answers from the box. Okay, give you a minute. Right, so before the student jumps, so they're stood up on a bridge. So anything that has been lifted up, remember, has the potential to fall due to gravity. The person jumps off that bridge, it's gravity that's pulling them down. So here is our gravitational. No way am I going to fit that on. So we're going to have gravitational P energy. When he's falling, the student's store of, well, as you're falling, it's movement. Movement, we're talking about kinetic. So their kinetic energy increases. When the bungee cord is stretched, anything stretchy is to do with elastic. So the cord stores energy as elastic energy. So the point the student gets to that stationary point, that lowest point, we've got this extended bungee cord. It's got that elastic store of energy, because then what will happen is that elastic store will convert back to kinetic store, and that student will rise back up. If that was me, there'd probably be a lot of sound energy as well, as I was screaming on my way down. Okay, right, let's have a look specifically then at kinetic energy. So let's, apologies if you just heard my doggies bark. I kicked the desk. They thought it was the door. So we're going to look at kinetic energy and how we calculate it. So you've got a pen and paper, you might want to write this down because you're going to need to learn this equation. Okay, now key things is knowing what units those different components are in. If they don't stop in a second, I'll just go shut them up. So it's what's knowing what those components, what we need, what units we need to have them in. Okay, so let's label these up. So here's our equation: kinetic energy equals 1/2 times m times v squared. So kinetic energy, we're talking about any type of energy, its units are joules. All energy is in joules. Just going to pop on there that 1/2, when you put it in your calculator, 0.5. That mass needs to be measured in kilograms. So be careful, if it's something that's relatively small and it's in grams, you'll need to convert it to kilograms. And then velocity is in meters per second. Okay. And we need to make sure that we square that value. Just going to tell my doggies to shut up. Sorry about this, guys. Yeah, sorry about that. Right, so let's have a look. So learn that equation. You will need to know that equation for your exams. Okay, but for now, we'll jot it down because we're going to work at it. Right, now lots of different schools use lots of different sort of like little mnemonics and things of how to set out your calculation to try and minimize the chance of you making a mistake and losing a mark. Okay, a school that I've worked at used something called HESQ. So it's highlight the numbers, what's the equation, do the calculation, what are the units. So you've probably all got your own little ways. So I'm not going to use one in particular, but we're going to follow the same pattern of steps. If you do use something like that, you probably realize I'm doing something very similar. So the first thing that I would suggest you do is to highlight the numbers involved. Now, this is a simple worked example. Often questions are a bit more wordy. Yeah, it might tell you what day it is, what time of day it is, what weather it is, and give you all sorts of bits of other numbers that you don't need. So if you highlight the numbers, when you're looking back at the question, you're less likely to look in the wrong place. So we've got a mass of 1,200 kilograms and we've got a speed. Okay, so we're going to highlight the values. The next thing to do is write down the equation that you're going to use, because you can score a mark for simply writing down that equation. Because even if you have no idea what to do with it, but you know what equation it is, it's still credit-worthy. You will still get some marks. Okay, so Ke equals 1/2 times mass times V squared. Now I'm going to pick out, I'm going to pull the information from that bit at the top, bring them down the side, so it's all in one place. I don't have to keep looking back into the question then. So I'm going to use Ke m V squared. So I'm going to look, do I know the kinetic energy? Well, no, the question asked me to calculate that. So I'm going to leave it as Ke. I'm not going to put it into a question mark. I'm not going to change the notation, because again, I'm just going to confuse things. I'm going to leave it as Ke. The mass, yes, it's there. I highlighted it. 1,200. It's in kilograms, so I don't need to do any conversion. Brilliant. V squared. So do I know this speed? Yes. 27. However, I want that squared. So I'm going to do that now so that I don't forget to do it later in my calculation. So if you've got your calculators handy, square me 27, see if you agree with me. It's 700, whoops, excuse me for just putting a line down there, 729. Right, now I'm going to substitute. Now I've got my numbers in one place, I'm going to substitute them into my equation. Because of the power of technology, I can just budge these across. And then I'm just going to change the colour of my pen so you can see what I'm doing. So Ke now, I don't know Ke, so I'm going to leave that as Ke equals, I'm going to convert my half to 0.5 because that's how I'm going to type it in my calculator, times mass, 1,200, times the velocity squared. So I did my 27 squared, which got me 729. So I can just type that into my calculator. I've done my squaring. Don't need to do anything else with it because this one's nice and straightforward. Substituting in my numbers. So you plug it in as well, just to check that we're getting the same answers, we're doing the right thing. So I get 437,400. So I've got 437,400. We're talking about energy, so with joules. Okay, hope you agree. So follow that pattern. I know it takes a little bit of time, but it really ensures that you don't make any mistakes. You're not going to lose any marks anywhere along the way. All right, so let's have a look at a question. So this one's another one, nice and straightforward. This is only worth 2 marks. This would be a question that would be quite early on in the paper, but do exactly the same process. I know you can't highlight it as such, but you can pull out those numbers and set it out the same way. So calculate the kinetic energy. So your command word, what it wants you to do is calculate, giving you the equation. So set out like I did, Ke, mass, speed, pick out what you know, have a shot at the answer. Give you a couple of minutes and then I'll go through it and repeat that process with you. Okay, just give you about another 30 seconds. Okay, let's have a look. So set it out exactly the same. KE M V squared. Right, I'm going to highlight what numbers I can see. Probably going to need them. And let's drag out my numbers. It asked me to calculate kinetic energy. Just leave that as a KE, not going to interfere with it. Mass, 80. It's in kilograms. Don't need to do anything. Speed of the cyclist was 12, but I need to square that. 12 times 12, I get us 144. And now I'm going to substitute it in. So KE 0.5 times 80 times 144. Again, nice and straightforward. Can just tap this straight into my calculator. I get 5,760. Okay. Right, let's pop you straight into another one. Again, nice and straightforward, just the 2 marks because it gives you the equation. It's giving you the numbers, so you've just got to select them, make sure you square your speed, and put it in your calculator. Okay, so again, give you a minute to have a go. Okay, I'm going to jump straight in with this one because we should be getting the idea. I'm going to highlight my numbers. Yeah, helps me. Don't have to keep looking back. Okay, let's pull those numbers out. KEM V squared. Kinetic energy, I don't know because there's my command word, calculate the kinetic energy. Leave that as it is. Mass is 62.5 kilograms, no conversion needed. And I've got 12 again. So 12 times 12, do that squaring now. 144. And now I just need to substitute 0.5 62.5 times 144. Put it in my calculator. Get 4,500 joules. Yeah, so if you write that equation out, even if I've written it out here, but somehow typed it in my calculator wrong, not got the right answer, I still can pick up a mark because I've done the right thing. So you still get a mark even though the answer is incorrect. This is why I like this process, this is why I go through this process, because it's trying to minimize any chance that you lose those marks. Okay. So this one I'm going to let you have a go at it first, but then I'm going to use it sort of as a worked example, because here, this bit you can do part A and part B. You'll absolutely smash that. But what I'm going to say here is here, look at the command word calculate, but this time we're calculating the mass of the diver. But start the process the same. Highlight it, pull out your numbers, substitute in. If you don't know then how to rearrange, that's fine. Pause there and hopefully you'll pick it up as I go through it. Okay, so I'll give you a couple of minutes, have a go at what you can, but if you're unsure how to rearrange, that's fine, I'll show you how. Just 30 more seconds. Right, okay, so first one hopefully was nice and straightforward. We've done a couple of these earlier. Choose the answer from the box. So we've got a diver on a diving board. As they fall towards the water, there's a decrease in, that will be gravitational potential. Just remember, anything at a height has gravitational potential. As they fall towards the water, there is an increase in their kinetic because she's moving towards the water. Write down the equation which links kinetic energy, mass, and speed. This is why you need to learn those equations. So EK equals a half. Doesn't matter whether you write a half as in 1/2 or put 0.5. Half times m times v squared. Same process. Let's highlight the numbers, see what we know. Okay, got one there. I've got energy and I've got a speed. Let's pull them out so I don't end up writing the wrong one. So do I know EK, m, and v squared? So this time I do know the kinetic energy. So I've got 5,040 joules. I don't know the mass. So just like before, I'm not going to put it as a question mark. I'm not going to change it in any way. I'm just going to leave it as m. V squared. I've got 12. Square it, do it now. So that's 144. Now I know I've got the equation written up there and that would get me the mark. Tick, I've already got that. However, I'm just going to rewrite it down here just so that I can substitute underneath. Yeah, so EK, whoops, 0.5 times m times v squared, just so you can see what I'm doing a little bit easier. So now I'm substituting in. I know what EK is, 5040, so that equals 0.5 times m, because I don't know that, times 144. Now what I'm going to do is I'm going to simplify. I'm going to simplify this. It doesn't matter what order I times these together. If I did 144 times 0.5 times m, still get the same answer. So what I can do is I can multiply 0.5 by 144, and then I'm only dealing with one set of numbers at that side. So I'm going to do that. So I'm going to type in 0.5 times 144, which gives me 72. Excuse me, 72 times m. Oh dear, excuse me. Okay, now I want m to be the subject of the equation. I want that on its own. So I need to get rid of that 72. So I'm going to bring that 72 over to the other side of the equation, which so you don't need to show all of these steps. I'm just really mapping it out so you can use it as a revision tool. So I'm going to write down here. So my 5040 divided by 72 will give me m. So if I put that into my calculator, I've got 120 kilograms. Hopefully you agree. Now questions, a little bit of insider info for you being an examiner. Questions that are worth 3 marks. You must write some form of calculation here. Some people are very good at visualizing the equation. They can almost rearrange it in their head. They tip-a-dap it in their calculator and they write down an answer. If you just wrote the answer, even if you got it correct, so you got the 120 kilograms, if you didn't put any calculation, if all those lines were just left blank and just the correct answer, you would only score 2 marks. You must write some form of calculation to gain that 3rd mark. Okay. So not only is it helping you lay it out, helping you reduce those errors because you're not going to look at the wrong bits, it also means that you'll gain those marks. Okay, let's do one last one. So we've got the same again. So if you weren't quite sure how to rearrange to calculate the mass last time, hopefully now you know what you're doing. It's 2 minutes and then I'll go through it with you.
For the last question, where it said 540 divided by 72, it kept saying 70 in my calculator.
Okay, I'll go back and have a look in a second. We'll
Okay,
go back to it. Thank you. Okay, guys, just going back then and addressing that question, because here, okay, what I did there is you're absolutely right. It is 70 kilograms, not 120. I did pause and question myself a little bit, and I thought that's quite a heavy man, but it could be right. I'd typed in 42. So number 4 is under number 7, and I'd made an error typing it in my calculator. Okay, so be careful. Okay, I've obviously then, you know, got this bit right, so I've done this correctly, but typed it in my calculator wrong. So I still would have scored 2 marks because actually I've shown that I do know what I'm doing. I just typed it in my calculator wrong. So hopefully that is perfect. Perfect error to show you why to write out your calculation. See if I can get it right this time. But if you think I'm wrong, you know, please do stick it in chat or something and say, don't think it's right. So the equation, should be smashing this by now. Oops, do not delete that, make it a bit neater. 0.5 times mass times v squared. Highlight the bits that I know. Numbers have I got? Okay. Pull them out. Separate out v squared. Kinetic energy is 270 joules. No conversion needed. Mass, I don't know. I'm going to leave it as m. V squared is 3 squared. Okay, so we've got 9. Do that squaring first, then we don't forget. Okay, now I'm going to substitute my numbers in. 270 equals 0.5 times m times 9. I'm going to simplify it. I'm going to do 0.5 times 9. Whoops, it's because I said number 9. Do that first just to simplify this side. M times 4.5. I want m as the subject, so I'm going to take that to the other side. So it then becomes the inverse, becomes 270 divided by 4.5 equals m. Make sure I type it in my calculator correctly this time. I get 60 kilograms, which makes more sense. The sort of an average mass of a grown adult, it's about 60-70 kilograms. That makes more sense than 120. Okay then, guys, I'm going to leave it there because that is quite a nice time to round it off before we move on. So we'll pause there. Hope you found that useful. Any feedback, please do drop an email in. If you want anything changing, what you enjoyed, if it was helpful. And hopefully I'll see you all next week. Thanks, guys.